Okay, so today we're going to continue on the next topic. We kind of dovetailed into it last time, motivating, what happens when somebody doesn't give you the correct number of command line arguments in a non-interactive program by creating a condition and issuing an error message and then quitting if you didn't. To do that, you need conditionals, okay? And normally programs, as we've seen, go in this linear order. It's a linear control, sequential control flow is what it's called. That if you write command, A, B, C, then it executes in that order. However, more complex problems require more complex solutions, right? And branching. You need to make a decision. Sometimes a program needs to make a decision. Is this person going to get a discount because they are, they're a student or something like that? Or they're above a certain age, therefore they get this amount of discount instead. And conditionals are how you can specify that one piece of code runs, or another piece of code runs, or this piece of code runs, or it doesn't run at all, right? And these are all going to be supported by if statements, if-else-if statements, or if-else statements, excuse me, and then finally if-else-if statements. And we're going to see that actually all three of these types of statements are exactly the same. It's just that the alternatives, the else's, those are all optional. And if you don't write them, then you don't have to. Conditions rely on some sort of logical condition. A logical condition has to be true or false. There is no in between, right? That this value, that A is greater than 10, or it's not greater than 10. It's less than or equal to 10, right? It's a binary decision, true or false, 0 or 1. It's called Boolean logic, right? And we're going to see very quickly, however, that in C, to do basic Boolean logic, you basically just rely on integers anyway. All right, so first of all, let me give myself some more room here. I'll pad out the bottom so that it always snaps up top. All right? So let's look at the basic syntax here. We got a preview of this last time by writing an if condition. And I'm just going to simply repeat that here, but with fake code, pseudocode. If condition, right? And then I'm going to, so I have the if keyword, right? And then within that, I've got parentheses. And within that parenthesis, I've got a condition. Now that wrangle, left angle bracket, right angle bracket is what we call those. And then the condition in there, that's not real C syntax, okay? We're going to come back and fill in the blank there later on. I just want to get down the basic usage and the basic syntax of how this thing actually works. So if the condition above evaluates to true, right? And unfortunately, there is no true keyword in C. You can bring in a library to do it, std bool. We'll look at that later. But if it evaluates to true, then this statement will execute. Right? Oh, and it is word wrapping here. Great. Right? Otherwise, it will not execute. Right? So this is what's known as an if condition. If the condition is true, then the entire thing inside this opening curly bracket and closing curly bracket, everything in there will execute. And it'll go back to the normal sequential control flow of A, B, C, D. Right? After this, if it's not true, then the entire program skips. It goes from that if condition evaluates to false, which is the alternative to true, then the entire thing will be skipped and normal control flow will continue after this code block. Right? Block, remember, are blocks of code. They're paragraphs, basically. Okay? So you also have an if-else condition, right? You can also write an if-else statement. Right? So let's go ahead and take a look at that syntax. Right. So if, and then we provide the condition. Right? And again, that's not real C code there. The wrangle, that's just a placeholder. We'll actually have a real condition here coming up. Right? And then this is statement A, say, and then else statement B. Right? So let's walk through this one. If the condition above evaluates to true, then statement A is executed. Otherwise, if it evaluates, otherwise, and I'll go with another bullet here. If it evaluates to false, then statement B is executed. Right? These are This is a term called mutual exclusivity. These are mutually exclusive, right? What does mutually exclusive mean? It means that one excludes the possibility of the other, right? It can, I can go to the hockey game this weekend, or I can not go to the hockey game this weekend, right? If I go to the hockey game, or say that there's another game, there's a basketball game and a hockey game at the same time, and I can't be two places at once. If I go to the hockey game, that mutually excludes the possibility of me going to the basketball game. Likewise, if I go to the basketball game, then that mutually excludes the possibility of going to the hockey game, right? Hockey, yay? All right, you should be proud of it, yes. Especially right now. All right, these are mutually exclusive. One or the other statement is executed, right? But it is not the case that both or neither, nor neither, are executed, right? That's what exclusivity means. I could, of course, choose not to go to either game, right? And that would be a third possibility that is not taken care of with a basic if-else statement, okay? These two things are mutually exclusive. One happens or the other happens. There's no other possibility, okay? You can also extend this to additional statements. You can extend this to a series of if-else if statements, as many as you want. So let me go into code mode here again. Right? If, and here I'm going to have multiple statements. So a conditional A, or condition 1, let's say 0, 1. And this will be statement A. Else if, condition 0, 2. And I'll keep it simple and only have these three, and then we'll extend it later. Statement B, right? Else, statement C, right? These are all mutually exclusive. Exactly one of these three statements occurs. If condition 1 is true, then statement A executes. Otherwise, if it's false, then it goes back down to the next statement. And if that happens to be true, then statement B executes. So it goes in order here, and order therefore matters. If both of those are false, right, false and false, then it falls down all the way to statement C. Right? You can see that this is simply just a generalization of this without the middle statement, and the if-else statement right here is a generalization of this, in which case I would put, say, let me go ahead and come up here and edit it, else, nothing, right? You can write code like that, but don't, right? What we had before with just the if and then no else statement is equivalent to an if with an empty else statement. So all three of these things are basically the same thing with more options or fewer options. I'm opting out of having an else condition right here, right? Don't leave dead code. That would be called dead code, right? That's cruft, right? That's extra stuff that doesn't belong in your code. Don't do it, right? Okay. You can extend this even further, right? So let's go ahead and note these things down. That the first condition in an if-else if statement that is true is the only one that executes, right? All conditions are mutually exclusive. Exactly one of them will execute. Therefore, order matters, right? Generally, you want to put the most specific conditions first, and then you get more and more general, right? So generally speaking, the most specific conditions are placed first. Then you generalize, right, as you go down. And what's the most general in this case? If all else fails, then do this thing, right? And that's the most general because it doesn't even have a condition, right? If all of these other specific conditions fail to evaluate to true, then what do? We do the only thing that's left to us, right? This else statement. And again, it is completely optional. If you don't want to do anything else, right, then don't write an else statement at all. Okay. Note, and then you can generalize to any number of conditions. Right? All you have to do is add more. So condition 1, condition 2, let me go ahead and add another one. Condition 3 and 4, right? Dot, dot, dot. Now, of course, you'd want to C and D and E, right? So you can have condition, 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 and you would write it all like this. So let's note the style tips, right? So where am I placing that opening curly bracket? It is placed on the same line as the condition, right? Or keyword, right? That is if, else if, etc., or else. And here's the dirty little secret. There is no else if statement, right? What is it? It's an else and then another if statement. That's all it is. When a compiler actually parses it out, that's how the language actually works. Other languages don't do that. Anybody have any Python experience? No? Okay, so what are the if, else, if statements in Python? If, elif, E-L-I-F, a brand new word, right? So there, they don't just tack on more and more if, else, if statements. They actually have a keyword that does it. And in fact, if you do an else if, I don't even think that it would run or something, right? And then they do have else, right? Yeah. At the end, yep. So some languages have a completely different word. Elif, E-L-I-F, that's all one word in Python. Weird, but true, right? So you can have as many as you want. And their opening bracket is on the same line. Each closing bracket is on the same indentation level as the if keyword, right? Generally, white space does not matter, but you should, the white space does matter with the else if, because else if, all one word, that's not a keyword in C. But white space actually does not matter. Actually, let me rephrase that. Generally, white space, you indent each statement code block. Right? I indented all of these statements. Statement one is A, B, C, and D, etc. Those are not real statements, by the way. But whatever they are, you indent them, and you indent them all at the same level, and all at the same level. Okay. What else is there? What else do you note? So just small things here. There is a space between the closing curly bracket and the else. This is not syntax. White space doesn't matter in general, but this is a good practice to follow. Space right here, right? Depends on what kind of space you want to put inside of the parentheses here. We'll get to that when we get to an actual statement. But otherwise, there's no space between the if and the condition on any of these things. Okay? That's a good style to follow. If you want to follow a different style, that is perfectly fine. For example, old school styles would have you do something like this. Let me go in just code mode here. If, condition, and then you have an opening curly bracket, next line, same indentation level as the I, and a closing curly bracket there as well. Statement A. There we go. Statement A, statement B, whatever, whatever, whatever. This is an old school way of doing it. It's a GNU style, I think. It doesn't matter. If you want to adopt this style, that's perfectly fine, as long as you are consistent about it. You should not mix your styles. There should not be one statement that looks like this, and then suddenly you switch styles later on, and you're like this, right? So when we grade for style on your hacks, we're grading for consistency. If you want to use a different style, that's perfectly fine. When you actually get into a company, you will have a style guide to follow, usually. The style guide will be published and say, we follow the GNU or GPL style guide or the Google style guide or something like that. And then you'll have to conform to that style. Go to a different company, you could be conforming to a different style. It doesn't really matter as long as you are consistent within the code base that you are working with. Okay? All right. I don't like that style, though, so I'm going to go ahead and get rid of it. It's all, subjective at that point. Again, order is important. So we actually need some conditions here now to work with. So conditions, numerical comparisons, right? That's the easiest to start out with. You can compare two numerical values They can be variables, literals, or expressions. Right? So remind me, variables, we have a pretty good understanding of that already. Int, number of students. If the number of students is greater than 5, right, then the class will run or something like that. We also have an understanding of what literals are, right? The 5 that I just mentioned. If you hard code a value in your code, 5 or 30 or 0 or something like that, that is a literal. That's a literal number that you put into your code. An expression can be like the expressions that we wrote. Negative b plus square root of b squared minus 4ac all over 2a, right? An entire expression can be in there. And you can make comparisons one way or the other, right? Or a mixture, right? So for example, you have less than, right? So what else would you call this? So is 5 less than 10? Yep. Is 5 less than 5? Nope. Strictly less than. Right? So that is an important distinction between less than and equal to. Right? This is less than or equal to. And we do write it like this. Why? Because check out your QWERTY keyboard. Do you have a less than or equal sign that you would normally see in mathematics? Nope. Something that looks like this. Less than equal. Right? That's not on your QWERTY keyboard. We don't write that in code. Okay. Well, you have the opposite. You have strictly greater than. You have strictly greater than, or not strictly greater than, but greater than or equal to. Right? What else do you have? What if you want to tell if two things are equal? Can we just use a single equal sign? Nope. That would be, it needs to be a double equal sign. Why? Equal sign already has a meaning. What's its meaning? It's an assignment operator. It takes whatever is on the right-hand side, evaluates it, that's a number, and puts it into the variable on the left-hand side. For better or worse, that's what we're stuck with. The vast majority of programming languages use something like this because that's what they started doing in the 40s or 50s or whatever, right? Granted, it would have been a lot better to use a single equal sign and then to use a different sign for assignment. For example, some languages use a left arrow. Take the thing on the right-hand side and put it into the variable on the left-hand side. C ain't one of those languages, right? If you've ever seen it, Haskell does something like this. Anybody use Maple? Or this might be an old school Fortran too. Colon equals is the assignment operator there, right? But the vast majority of programming languages use the single equal sign because it's familiar, it was established a long time ago, and therefore we are forced to use two equal signs for equality. What about inequality? If I were to write this in a math class, what would I write? Equals and then a slash through it, right? We don't have that on our QWERTY keyboard, so we use the thing that looks kind of like it, an exclamation point, and then a not equal sign. Some people on boards will do something like this. I've never seen an actual programming language that does something like that. Instead, it's just not equals. Right? So anytime you see an exclamation point in code, it usually means not. Right? It's the negation of something. True becomes false, false becomes true. Right? And this is inequality. Right? All right, so all operands all operators operate on two operands only, a left-hand side and a right-hand side. Right? All values must be numerical values. Right? You can't compare a string that says hello world and another string that says hello world with any of these things because those are not numbers. As we've seen already, if we try to treat strings like numbers, bad things happen. When we prompted somebody for a weight, right, a number of pounds or number of kilograms, whatever it was, and we mashed the keyboard, or we said TEN for 10 pounds, did it work? No, because T is not a numerical value. So you can't use numerical operators like this, comparison operators, with non-numerical values. Right? And we'll learn the consequences of that later on. Operands, again, can be variables, literals, which are actual numbers, or expressions. So for that, let's go over here. Oh, come on. To our, and give some demonstrations over here. Now, I'm still using the CS50 IDE over here as a backup. Looks like it disconnected, so I'm going to go ahead and refresh that while I'm talking. But as you might have seen, there has been a notice that was put up there maybe a week or two ago that they are sunsetting the CS50 IDE in favor of, this is a AWS product, Amazon Web Services product. Actually, it's another company called Cloud9 that they've been using for years. They've switched over to a Microsoft product. This is VS Code. This is a browser version of Visual Studio, basically. And it is actually quite nice if you want to get into it, because you can persist workspaces between your desktop version of VS Code, that's Visual Studio, which is IDE, and your VS Code on the browser. So that if you've got your, if you do things on the browser because you don't have your computer with you, it will sync up with your other stuff. So if you want to start using it, be my guest. I might start using it simply because it affords me a little bit more real estate than over here. The layout is a little bit better, and I like it a little bit better. But we'll go ahead and try it. There might be some things that are not installed that are essential. When we get to that point, I will hopefully have a solution for you, or we'll just go back to the CS50 IDE. They're not going to be shutting it down anytime soon, so don't worry about it. Certainly not until the end of the semester, probably. All right, so let's go ahead and create some variables here. Int A is equal to 10, int B is equal to 20, int C is equal to 30. Right. Now let's make some variables, or make some statements. So if A is greater than 5, printf, A is greater than 5. Is this going to print true or false? Or is this going to print anything? Let's find out. Oops, I need to be in main. There we go. So is this going to print anything? Is this going to print the message A is greater than 5? Yeah. All right, A is greater than 5. If I did the same thing with 10, is it going to be true? Is the value stored in A greater than 10? No? All right, so it's not going to print. So we can put an else statement there. Else printf A is not strictly greater than 10, end the line. And this will actually print, and we'll see that it prints the second message instead. Right? A is not strictly greater than 10. Right? Is this too small for anybody back there? Okay. All good in the back? All right. Are there screens in the back of those screens? They should just turn those screens around for everybody. Okay, anyway. You can also mix in expressions. So for example, I am comparing a variable to a literal value. A is a variable, and then on the other side, I've got an actual literal, 5 or 10, a hard-coded value. You can go ahead and make it so that both of them are variables if you want. Printf, A is greater than 10, or than B. And the line, right? Else, here, come on. Printf, B is greater than A. Which one is going to print there? Which one is greater? B is greater than A. Right. Okay. You can also make expressions. If A is equal, or actually, let's go with A is equal to C minus A, or B. There we go. Printf, A is equal to C minus B. Is that going to print or not? What were the values? 10, 20, 30. So how does this go about evaluating this stuff? It evaluates both sides independently, comes up with a value, and then makes the comparison. Right? A is 10, so is 10 equal to 30 minus 20? 30 minus 20 is 10, so are they equal? Yes. Did I write my code correctly, though? Okay, well, let's find out. A is equal to C minus B. So we predicted that it would print, right? Okay, but there's no problem. Let me go ahead and give myself some more room in the terminal here. And remember what I showed you yesterday, or on Monday, whatever it was? There's this other flag that you can turn on all the warnings, the wall flag, right? So before, when I was compiling this, no problems. Right? Now let's try it again, but with all the warnings turned on. Is there going to be a warning issued here? Yeah. What's that warning? Suggest parentheses around assignment as a truth value. So what?
You need
two equal signs. Right? What was I doing before? It's the assignment, right? So C minus B is equal to 10. So take the value on the right-hand side, 10, and put it into the variable on the left-hand side, A. So 10 goes into A. Well, as we'll see here later on, 10 is evaluated as true. And so this gets evaluated as true, and we end up with this. Just to show you that the consequences of this, let me go ahead and go with B minus C instead. A is equal to B minus C with only one. And again, if you compile it with no warnings on, okay, sure, do what you want, right? But now is that last message going to print? A is equal to B minus C. First of all, should it print? B minus C is, what was it again? 20 minus 30, which is negative 10. Is 10 equal to negative 10? Oh, apparently it is, right? Right there. Why is it? Well, because B minus C is going to be 20 minus 30, which is negative 10. Take the value on the right-hand side, negative 10, and put it into the variable on the left-hand side, A. Negative 10 is evaluated as true. In C, 0 is false. Anything else is true. Negative 1 is true. Positive 1 is true. Negative 3.5 is true. 3.14159 is true. Right? The only thing that is false is 0. Everything else is true. Okay? So be careful. Right? When I correct this, then I do not get that last message anymore. Right? Yep, I don't get that message anymore. Right? So take care. You can also have full expression. So actually, let's do an if statement here. If, let's create some more variables here. Int home score is equal to, I don't know, 10. Int away score is equal to 14. Right? So if the home score is greater than the away score, then we'll print out a message here that says, I don't know, Mavericks win. Right? Else, if home score is less than the away score, then printf, Mavs lost. Oh well. Else, printf. What's the only other possibility here? Something. Is it a tie? All right. Tie, go to OT. Right. There we go. So what's it going to print in this case? Those aren't hockey scores. Come on. 3 and 4. There we go. Not a bad win. So who's going to win in this case? The other guys. So it'll print what? Mavs lost. Let's flip that score. 4 and 2. Now here, what's going to happen? Mavericks won, right? What if they are both equal? Well, then that's where we get the tie. All right? And I didn't put an inline character in there, so it's not going to look pretty there. Right? Is it okay to do this? Home score is equal to away score. Right? That's equivalent, right? That's the only other possibility, and that also means that it's a tie. Is it necessary, though? No, because of mutual exclusivity. Exactly one of these things is going to execute, and only one of these things is going to execute. So if you've exhausted all possibilities, either one team wins or the other team wins or there's a tie, you don't need a condition for that last one. Now you could have switched these conditions around. You could have checked for the tie at first. Then you could have checked for the Maverick win. Then you would have just had to have an else statement down there. It is syntactically correct and logically correct to write this. Stylistically, don't do it. Right? You don't write more code than you have to, because more code is more code that somebody else has to read. It's more code that somebody else has to understand, and it's code that's not necessary. It's that cruft again. Right? Get rid of it. Okay? All right. Let's see another example. So you can, but shouldn't, do something like this. If 10 is equal to A, right? Printf, A is 10, end of line. By the way, what was it? It was 10, so this will be true, right? Syntactically, it's okay to write this. Logically, it's okay to write this. Stylistically, is it okay to write this? Read this out aloud to you, or in your head. If 10 is equal to A, is that how we speak? Or is it, if you were to say something like this in regular Old English, would you say, if A is equal to 10? Which one of those sounds better in your head? The first, A is equal to 10, right? So write code how you would speak code. Write code how you would read code. Yes, this is perfectly fine logically. It's perfectly fine syntactically, but don't do it. Right? Now, there are a couple of instances where you can break this guideline and break this rule. We'll get to those eventually. Okay? Then you can also have entire expressions. You can also evaluate expressions. So, for example, if b times b minus 4 times a times c is less than 0, what am I computing there? B squared minus 4ac. That's under the radical. There's a name for that. What is it called? The what?
The quadratic equation.
Yeah, the quadratic equation. What's that one part of it under the radical called? Discriminant. There you go. That's the discriminant. Why? It discriminates between real numbers and imaginary numbers, not fake numbers, but imaginary numbers. So we would have an imaginary number in this case, right? Because we're trying to take a square root of a negative number. Can't happen. C does not support that. You would need to bring in a library or something else. There are ways that you can do it. There's a complex.h. It's not well supported though. But in any case, we're not going to get into that. So I'll go ahead and print an error message here. Printf cannot handle imaginary numbers at this time, right? But the takeaway on this is that you can have an entire expression here, and then you compare that entire expression to another literal, or to another expression entirely, right? A squared is less than b minus c, or something like that. You can have an expression on either side, okay? Now, if you do have that, then you might want to look for algebraic simplifications, right? If you've got a squared is less than b minus c, take those onto the other side, and then you compare it to a literal over here or something like that, right? And it might flow a little bit better. Write code that is readable. Write code that is not necessary. Don't write code that just shorten it up for the sake of shortening it up. Don't write code for the sake of being clever. Write code for the sake of readability. Okay? All right. How can I check if something is even or odd? Check if a number is even or odd. If A is even, can you do that? No. So how would you know if something is even? Divide by 2, and what would the remainder be? If it's even, it'll be 0. Now, can I do that with the division operator like that? What if it's 10? 10 divided by 2 is going to be what? 5. Right? I want the remainder, not the quotient, whatever it is. Right? So how do I get the remainder? Percent. Right? Else, if a mod 2 is how we read that. The only other possible remainder is 1. We print f, odd. Now again, is that additional if necessary? There are only two possibilities, even or odd. What is 0, by the way? Which one is 0? Is 0 even or odd? It's even, right? 0 is neither positive nor negative, but it is definitely even, okay? So, do we need that? No. Okay? All right. You can, but should never, do something like this. If 10 is equal to 20, printf, crash, whatever. Right? Why should you never do something like that? Is 10 ever equal to 20? No. The left-hand side is a literal, the right-hand side is a literal, right? You know what those are before you even compile it. Before you even wrote this code, you knew that 10 is not equal to 20. Why are you predicating this code on something that is never going to be true? This is always going to be false, right? The above, oops, let me put it in over here. 10 equal to 20 is always false. It is a contradiction, right? Something that is always false. And this, thus, the above is dead code. Right? It is code that will never execute under any circumstances whatsoever. Let's see if the compiler can call us out on that. Nope. Even with all warnings turned on, it's not going to complain about that at all. Okay? Likewise, you can, but should never do the following. If 10 is not equal to 10, or sorry, 10 equal to 10 is what I want. Printf, yep. Why should you never do that? Yeah, it's not dead code anymore. It's just always true. What is something that's, there's a name for that. The above condition is always true. It is the opposite of a contradiction is a statement, fact. What about in logic? What do we call that? A tautology? Anybody have any logic yet? No? Okay. Something that is always true is a tautology, right? Or they talk about it in philosophy too. So something that is always true is a tautology. Don't write the statement. Don't write the if condition. Just write the statement, right? In other words, if you want to print yay or yup, then just print yup, right? Whatever you were going to put in that code, just put it. You don't need to predicate it on anything, okay? All right, going back, I'll make sure that you have this in the notes here. Any questions so far, or you want to see anything, any other variations on this stuff? No?
What about square root?
Okay. What do you mean square roots? Like if you wanted to do something like, here's the root is equal to negative b plus minus, something like this, you can't do that. You're going to have root 1 and root 2. And then one of them will be the add, and one of them will be the negation. You can always create more variables, right? You don't have to pay by the variable. Yeah?
So if you have like some like function with an order of operations or something in it, returns a square root, and I know we'll like return that as a decimal, but will it always return a positive value unless you like tell it to?
Well, a square root will always return either a positive or 0, because the square root of 0 is going to be 0. But a square root is always going to be positive. Actually, sorry, here. All right, good question. Double x is equal to square root of 2. Let's print that out. X is equal to percent f, right? And we'll print out x. That's one value. That should be pretty straightforward and clear what it should be, right? 1.41 something
That
something.
will always return positive though, because there's like a positive and a negative.
Yep, careful.
That always returns positive unless you do something else.
If you do something funky like this, let's find out what happens here. What would this return here? Oops. By the way, what do I have to include if I'm going to use the square root function? Hyphen lm y to link in the math library. There we go. Now the first one is going to output 1.41 blah blah blah, whatever it is. The second one though, in mathematics, what is the square root of negative 2? With what behind it? With an I behind it to indicate that it's an imaginary number. Let's find out what C does in that case. Nan, right? So it is a negative, but it's a negative nan. Nan, what do you think that stands for? It's not a number, right? It's not a number that C understands. You're going to have to bring in some sort of a library to handle complex values, imaginary numbers, right? And so the result of certain things will always get you nan. Sometimes you'll get inf or negative inf. For example, x is equal to, what is the log of 0? What is the natural log of 0? What does the log look like? So it goes, as it approaches 0 from above, what happens to it? It goes down to negative infinity. We do get negative inf. What is infinity minus 1? Infinity. What is infinity plus 1? Infinity. What is infinity times infinity, or 1 times 10 times whatever? It's always going to be infinity. Once you're trapped in not a number, or once you're trapped in infinity, the game is over, right? You're going to have to reset your values. Quit out of your program. Use a different default. Prompt again for new input, whatever. Right? So those are some corner cases that happen. What's other bad math? Oh, go ahead, yeah.
So when you get the result of NaN, is that just given as like a string or like a sequence of bytes, or?
Good question. The IEEE standard probably has some sequence of bytes that indicates a flag value of invalid. What exactly those bytes are, I have no idea.
But you'd have to check those in NaN.
Well, you can check if something is nan. Let's see, man is nan. Nope, man is nan. There is a way for checking it. C, check for nan. So you could probably do it in the same C++ as well. How to check for it? Okay, you can use the comparison operator. You might need to bring in the the math library though to do it. Is nan? Looks like you set it to this. So let's try this. If x is equal to nan, I don't think that that's probably spelled correctly. We'll find out. Printf x is not a number. We can try troubleshooting this though and see if it works. All right, nope. Nan? Okay, there. There we go. But it's not printing that out. So, because it's not a number. It's not a number. What was it? It was inf, right? Okay, I don't know what that is either. Nan. So let's reset this so that it is nan, and then it should print out now. There, nope, it's still not printed out. So you're probably going to have to read some documentation, RTM, to find out what you should be checking for. Looks like they manually set it. So see, it should be an isNan, but that's not here. Whatever. It's in the C math library maybe? But we were already bringing in the C math library. Nope. So you've stumped the chump. We're going to have to read some documentation to find out. Right. Other questions? Okay. So go back over here to the notes. All that was still in the notes, so don't worry, it's gone. It's not gone. Again, pitfalls. You cannot use numerical comparisons for strings. In other words, you cannot do something. You cannot, or should not, I should say, do something like this. If hello is equal to hello, right? Now, of course, that you shouldn't do that anyway because that would be a tautology, but that would actually end up being false anyway, probably, because those are two distinct strings. What's happening is that equals equals operator is actually comparing memory addresses. Certainly, this would not work if it's equal to goodbye, right? Good bite, right? Unintended pun there, right? So you certainly cannot do something like this. Right? You can't compare strings using these numerical operators. In other languages, you can. Python, PHP, JavaScript, I believe. There are ways that you can use these numerical operators, and then it switches over to string comparisons. That's not built in to a lot of languages. C, C++, Java, C#, you can't do anything like this. Right? C, it will compile, but it will not give you the results that you want. Right? It ends up comparing memory addresses in the machine. Right? You also have a general negation operator. Negation, there we go. So any statement can be negated using the single exclamation point. Just as we use a single exclamation point on an equal sign to make it not equal, you can take an entire expression and completely negate it. So for example, you can negate A is greater than B. But would you want to? Right? What's the equivalent and maybe better way of writing that? It is not the case that A is strictly greater than B. No? A is less than or equal to B. Right? This is better. Why is it better? Because read it, right? Like I said with the first one, it is not the case that A is greater than B versus A is less than or equal to B, right? So sometimes you do want to negate statements, right? But a lot of the times you can probably take that logic, twist it around, negate the logic itself, and then get a better example. And this goes into the KISS principle. This is all over the place, and especially engineering. What does KISS stand for? Keep it simple, stupid. Right? Simpler code is generally better code, but again, it needs to be readable code. Right? Simpler code is easier to read, easier to understand, and thus easier to maintain. If somebody's got to make a change, you don't want to waste your time simply understanding what they did before, because then you get into this feedback mechanism. You look at some code, and it might be nice code, it might be correct code, but there's just this one little edge case or this feature that you have to add to it, and you're reading it and reading it. I can't understand what this is doing. Screw this, I'm going to go ahead, I'm going to rewrite the whole thing, right? And you end up rewriting the whole thing, introducing 5 new bugs to the bug that you just tried to fix. Yeah, the bug that you just tried to fix is gone now, but you've introduced 5 new bugs because you started from scratch, right? Whereas if the code was readable and understandable, grokkable is what we call that, right from the front, then it's going to be way easier to maintain. So here's another nice terminology. Grok. Anybody know what that's from? Oh yeah, go ahead.
Isn't it from a sci-fi book?
Yeah, it's from a sci-fi book. Dang it, I've read it. It's Robert Heinlein. Dang it. Anyway, it's a term coined in that book. Look it up. It's Robert Heinlein Grok, and let me know what it is. And it's a human that was raised on Mars. Stranger in a strange land. Thank you. And they had this idea of intuitive understanding. Once you understand something completely, right, just by looking at it, right, grokking it, and that's what they called it in there. So it's been entered into not the common lexicon at all, but it's definitely a nerd lexicon kind of thing. Where do you grok Linux, right? Do you understand Linux just intuitively and get it right away, right? So grok, to intuitively understand something. So your code should be easily grokkable. Just by looking at your code, it is self-documenting, and somebody who understands that language immediately understands what you're trying to do, right? All right, you also have Boolean variables. Right? By default, C does not have Boolean variables that you can store true or false in. Right? Neither, and also, true and false are not keywords in C. Right? You can bring in a library, stdbool.h. What do you think that stands for? Standard Boolean, right? To support true and false, but there and variables, and maybe variables. But that's just what we call syntactic sugar. So what, have you ever heard of the term syntactic sugar? Right, so what is sugar in real life? It sweetens things, right? You have regular old Rice Krispies. Put some sugar on it. Now it's nice, right? Well, you also have regular old code. Put some sugar in your code. And now it's a little bit nicer to use. It's a little bit easier to use. And in this case, this is just syntactic sugar because in C, any 0 is associated with false, and any non-zero value is true. 1 is true. 1, 1.5, 4, 3.14159. What else? Negative 42, right, are all true. Only 0 is false, right? 0, right? So when I say that the standard Boolean library is just syntactic sugar, it's just a way that you can bring in the keywords true and false and use them. So let's go ahead and check it out over here. So without using that library, we can go ahead and establish a Boolean variable by using an integer. Int is student. Right? And I can set it equal to 0. What does that do? Sets is student to true or false? False. Right? Later on, you can go ahead and use is student and set it to, well, 42. Right? That's true. 31 is true. But if you're going to do it this way, why use exotic, weird numbers, right? Weird magic numbers. What should you use? 1, right? Sets is student to true, right? But any non-zero value would do. So you can use this in an expression. If that person is a student, is student equals true, right? You can't do that. Why? Without bringing in that library yet. I'll show you that in a second here. But there is no true, right? Okay, equals 1.
Student, right?
Say what?
Do you need the 1, or will it?
Hold on to that thought in a second here. We are going to shorten it up. You get a discount. And you do get a discount. I think in the student section at Mavericks, you get, what, 10 bucks? Maybe it's free even. Nobody goes to hockey here at all.
It's free, I get it.
You get free, right? I have to pay 40 bucks. Say what?
They just scan your card and then they let you in.
Yeah. Anyway.
You just gotta steal one of our cards.
Will do. A student on UNL campus pointed me to a VPN that you can use, and it makes it look like you're living in the dorm and get free cable. So thank you to them. But you're right. Do I have to say equals 1? No. In fact, I shouldn't. Logically, that's the same thing, right? It's still true. They are still a student. But are they going to get that discount under this condition right here? No. Because you were expecting a certain value of true. You were expecting a certain truth, right? So instead, what if you just wrote it like this? A Boolean value, a numerical value in this case, will evaluate to true, some non-zero value, or it'll evaluate to false, 0, in which case you've simplified your code and you've protected it against the weirdos that use 42 for true instead of 1, right? So it's much better to use this.
So if you don't put like an equals, and then, like if you don't put an equals, and then a number after it, it always is going to test if it's true.
It's going to be true. Yep, it's always going to make it into true or false. How do I make it into false if they're not a student? Not, exactly. You pay $40. There we go. You, not discount, but you pay 40 bucks. All right. So there we go. I'll put this into the notes as a demonstration. Questions so far? Or other tips about getting into Maverick hockey for free? Any questions? No questions online yet. Okay. Then I mentioned you can also bring in the standard Boolean library. So let's change all that code. Let's undo that. And let's bring in the standard Boolean library. Include stdbool.h. Why not standard Boolean library, right? Well, back then they were paying by the character, right? So let's look up the man pages on std bool. Oh, tutorial, okay, fine, that works too. False and true are now words that you can bring in, and you can create a bool variable. Again, this is just syntactic sugar. These are basically aliases. Under the hood, it's still using a bunch of integers to get the job done. It is defining, just like define pi to be 3.14159, or define pounds per kilogram to be 2.2 whatever. It's defining true to be 1. Define false to be 0. So it goes through your entire program and changes any instance of true to 1, false to 0. Yeah?
So is that considered the thing to do then, is to use that library?
You can. I don't know if it's interoperable, though. It's definitely available. You can do it in your assignments and stuff like that. Whether or not a particular embedded system, for example, brought this library over, I don't even know what the standard is, man std bool. Nope. So I don't know if it's ANSI C or C89 or whatever. You'd have to really read the standards, but and to find out. But for the most part, you can get away with it, right? Because you could still do something like this. In fact, this will still compile, right? Why? Well, because this is just an alias for int, likely, and 0, we could change that out to false, and it's the same as writing 0. Right? Otherwise, you can use true, false, all over. And then same as before. Oh, here, I'll get rid of this. Much better to use that, much better to use that. GCC, and run it. There, you get a discount because you are a student. Okay? So there's the alternative, bool, and then you can set it equal to false, set it equal to true. Let's find out if that is case sensitive. So false, false. It is case sensitive. It will not allow you to go all caps false. So you do need to use lowercase on that. At least that's nice. Right. There are some languages that, off the top of my head, oh yeah, PHP, it's actually case insensitive, I believe. And Python, what is it? Capital F, AL, and then the rest of it is lowercase, capital T, the rest of it is undercase, and it is case sensitive. Right. Yeah, gross. All right. So you can have complex logic expressions using connectives. Complex, there we go. You can use logical connectives such as and or. And I'm not highlighting those as code because neither one of those keywords is supported in C. In Python, you do use and or, but in C, you use other symbols. The logical and operator is true if and only if both of its operands are true. Right? The syntax is that you use ampersand, ampersand. Right? That's right above your S on your keyboard. Ampersand, 2 ampersands, not 1 ampersand. 1 ampersand is similar, but it has a different meaning. It's a bitwise operator. And if you do bit twiddling, again, if you get into embedded systems and stuff like that, you will be using it. But here, you don't want to use it because it's bitwise. It will give you completely different results. You want the and, right? And that's that we just read it as and, though. Right? So, for example, if A is greater than 10 and B is less than 5, right? Both of those conditions have to be true, right? For this to evaluate to true, right? If either the first or the second or both conditions evaluates to false, the entire expression is false, right? Only if both sides are true is the expression true, right? The other one, the logical or operator, is true if and only if and here I'll highlight it, at least one of its operands is true. The syntax here is double pipes, right? Or shepherd strokes or vertical bars, whatever you want to call them. And an example, I'll just use the same example as above. A is greater than 10 or B is less than 5. Okay? And it is true if the first is true. It is true if the second is true. If it is true if both are true. It is false only if both are false. So it's not an ultimatum if. In regular old English if, you can have cake or ice cream. Cake or ice cream. Does that mean that you can have both? Not usually, right? But logically, yes. So of course you said that I could have both because you didn't preclude that, right? Well, in English we mean exclusive or. Sometimes that's written as XOR, right? Exclusive or. That means that you can have cake or ice cream, but not both. Right? And also, you have to have one or the other, right? It's the mutual exclusivity again. But this is the logical or. You can have cake, ice cream, or both. It's just that you can't have neither, right? They're forcing you to eat sweets. Right. All right, so comparisons with characters. You cannot use the equals operator for strings, right? You can use them for single characters. So for example, let me go into code mode here. You can say a character input, and I'll say that I read it from the user or something like that, and I'll have, say, capital A here. You can use an equals sign on this, right? Actually, let's go ahead and go Y for yes, N for no, right? So if input is equal to Y, then execute command, right? They were asking you for, and this is just a function, say, we'll get into that later, but it does something, right? So we're asking somebody, are you really sure that you want to execute this program? Yes or no? They hit yes, and they execute the program. This is for a capital letter, though, right? What if we wanted to allow them to enter a capital or a lowercase y? How could we do that? If it's equal to y, or input is equal to lowercase y. If they answer y uppercase or y, they were holding down the shift key or the caps lock was on, right? Then we're not going to force them to just always do caps. If either one of these is true, then we'll execute command. Right? If they enter anything else, however, then it won't execute that command. Okay? Why can you do this? Why can you do this? Right? Remember, what are chars? Characters types are just ASCII text values in a big table associated with numbers. What is the value of capital Y? Does anybody know? Does anybody have their ASCII text tables memorized? A is 65. I have that memorized, so if you just start doing your alphabet in your head, you'll eventually get to it. It is 89, right? So that's equivalent to simply just asking whether or not this input value is equal to the character 89. Right? And that's why you can use these equals signs, because single characters are nothing more than numbers. Right? That's a truth. That's a universal truth of computers. Are there actually strings in computers? Are there messages that say hello? No, it's just a bunch of binary, zeros and ones. Everything when it finally gets into a computer is, at the end of the day, just a number. Right? So keep that in mind. Right? Let's see. A couple more pitfalls here. We'll conclude with a couple more pitfalls. So consider the following. I'm going to go ahead and cut and paste this, and you're going to tell me what it's going to do. Printf hello, and the line. There we go. What's going to happen here? Can you write code like this? Let's find out. Oops. I wonder if they've got A style here. Remember A style can reformat stuff nicely for you. Demo, there we go, yay, nice. So I didn't have to indent everything on myself. Right? So let's go ahead and create this variable A, and we'll set it equal to something that's in this range, right? What am I obviously doing? I'm checking to see if A is between 0 and 10 inclusive on both ends, right? So let's select something that's in the middle of it. Oops, okay. Ignore that for a second. There, ignore that. Right. There we go. Let's run it. Is this going to print hello or not?
No.
It does. Right. Let's find out. It compiled just fine, by the way, once I suppressed all the warnings. Right. Let's go ahead and try something on the end. It should print hello, right? And it does, okay. We're doing good so far. 10. Still hello. We're still good, right? Now let's check for something that should not print hello. Maybe -5. That's outside the intended range, right? Well, so it should not print hello, but it does. Right? Let's change it to 15. Something that is on the outside of that domain, but the other way. And it still prints hello. It will always print hello. Why? Read this left to right. So let's go back to, let's go with 15 here. 0 is less than or equal to A. Is that true or false? It's true. Right? What is true? True is 1. Right? So 1 is less than or equal to 10? True. Right. Let's go with -5 here. Is 0 less than or equal to A of -5? Nope, false. So what's false? 0. Is 0 less than or equal to 10? Yep. So that's why it always prints hello. Don't write code like this. What should you do instead? Well, what should you do instead is always make sure that you are going with the wall flag. Why? Because it gave you a spoiler. That's why I was trying to get rid of it really quick. It's telling you exactly what's wrong here. The comparison with constant 10 with Boolean expression is always true. It's always true. Why are you doing it like this? Right? Comparison with x less than or equal to y, less than or equal to z, do not have their mathematical meaning. Right? Code is not mathematics. It looks like mathematics. In many ways, with PEMDAS and things like that, it behaves like mathematics. But we've already seen numerous examples where it doesn't behave like mathematics. It doesn't support complex numbers, right? It doesn't support arbitrarily large numbers. You can't express a number, an integer value greater than 2.147 billion, right? There are finite constraints placed on all computers because they're finite objects. They're not math objects, okay? So you have to write this differently. How would you write this instead? Two statements. If A or 0 is less than or equal to A, and A is less than or equal to 10, then print hello. Now, I am violating that idea that I said before where you shouldn't put scalars first. Now, if you use that, that was a guideline. If you use that as a rule, you would have written this as A is greater than or equal to 0 and A is less than or equal to 10. You could have written it like that. A is greater than or equal to 0, but then it kind of takes the flow off, right? You've got a range here. So this is one of those instances where I'd say, yeah, violate that guideline because that looks a lot better, right? That looks a lot clearer, right? And that will work. The first one will print still because it's a tautology. Goodbye. But the second one will not print now. Oops. And I'm still getting a warning, but it's letting me do it. There we go. Hello, but it does not print goodbye. Okay? So this is the fix. And again, it's the above always evaluates to true. Reasons given. Right? Instead, use the following. Okay? Here's another pitfall. We've already seen this one, though, so you know exactly what's wrong. what's going to happen? It's going to be, careful. Let's try it. Int a, if a equals 10. We'll go ahead and set it equal to 10. We'll go ahead and set it equal to 9. So it should printf equal. And let me go ahead and put an else statement here just so that we can get something to look at, not equal. There we go.
Won't that print equal every time?
Forget that warning. There we go. All right. What will it print? It'll print equal no matter what. If it's equal, if it's not equal. Why? This is the assignment operator. Put the value 10 into A. The one instance in which it will print not equal is this if you set it to 0. Put 0 into A. Evaluate A. What is 0? False. So in this case, it will print not equal, giving you the correct answer, but for the wrong reasons. All right? Now, go back up to how we were compiling it before, and guess what? If you turn on warnings, you can catch errors like this. Always just get in the habit of using the wall flag all the time. Right? It's telling you something. Warning, suggest parentheses around assignment operator uses truth. Do you really want to do that? Again, it's lint. What is lint? Your clothes are clean. They just came out of the dryer. But you've got little pieces of lint on it. Right? It doesn't mean that your clothes are dirty. It doesn't mean your clothes are wrong. Right? It doesn't mean your code is wrong. It just means that you've got things on there that, did you really mean that for that to be there? Question?
Are there any limitations when it comes to putting expressions in, like when comparing expressions?
Not really. Any valid mathematical expression can be used in an if statement. And you can use assignment operators in an if statement too. And that is a common trick, but tricks are for kids. Let them do it. Keep your code readable. Avoid tricks, all right? Because tricks are not maintainable at all. Right? In fact, you can get fancy, you can get clever, and you can play games like code golf. Have you ever heard of that? So you write a piece of code, you have a task, and you need to write a piece of code that outputs this thing. And, oh, okay, I can write a piece of code that is 10 lines long to do that. Well, I can write a piece of code that is only 5 lines long. Why is that better? Why is that better? Because it's golf, right? Lower score, better. I can write a piece of code that does that in 1 line. Oh, okay, I can do that in a 1 line, but only 5 characters or whatever, right? And you can play code golf like that, but you don't want real code as a result of that code golf and that clever code, right? All right, we'll look at more pitfalls next week. But this week, on your hack, it's all just basic input-output stuff. No conditionals yet.